Welcome everybody to today's Believe in Serverless session. Today we have an AWS hero, co-author of the Node.js Design Patterns book, and big advocate for Rust, Luciano Mammino. He's going to be giving us a talk called Harder, Better, Faster, Stronger Lambda Functions with Rust.
Harder, better, faster, stronger.
Luciano, welcome.
Hello, Andre. Thank you. Hello, everyone else.
How are you doing today?
Yeah, very excited. Really excited to be here. So thank you very, very much for having me.
We're excited to have you. I'll let you get started with the talk. So let me pull up your slides. And I'll get off screen. I'll be in the background. Call me up if you need anything. Thank you, Luciano.
Thank you. All right. So I want to start with a little bit of an icebreaker. So this was the original title that I proposed for my talk. But of course, when I proposed that to Allen, he said, no, you should be using this other title. So my gift to him is that I think he's the best person to ask for title ideas. So if you ever need to get title ideas for your talk, you know who to ask for. Okay, let's get to it. And let's start by saying, or at least let's try to describe what is Rust. And at this point, you're probably asking, really? Again, I mean, how many times do I have to listen to people talking about how cool is Rust and what it is? You probably know what it is. So I'm just going to cut the bullshit and I'm going to tell you, why do I personally like Rust? And one thing that I like, and this is also a bit in the context of Lambda, which we're going to get into in a second, is that Rust has a concept of zero cost abstractions, which basically means that if you use specific features, these features will be compiled and included in your final binary. But if you are not using features, they don't get compiled into your binary. So that means that you are going to get effectively only the things that you actually need. And that means that your executable is going to be very fast at bootstrapping because it doesn't have lots of stuff that you are not using. There is a very, very good type system, which is considered strongly typed. It takes inspiration from other languages like Haskell. So it's really complete, and it can help you a lot to model your business logic in a way that will help you to make your programs very resilient. And as I said, Haskell is one of the aspirations, but it's not the only one. You can see things from C++. For instance, that idea of zero-cost abstractions comes also from C++, OCaml, JavaScript, Ruby. All these languages somehow provided inspirations to Rust. And this is, I think, one of the advantages that Rust has compared to other languages, because it's still relatively new. It was able to draw inspiration from all the good things that we learned from languages that came before Rust. There is a built-in package manager that is called Cargo. We're going to see a little bit of that today. But the idea of Cargo is that it comes built in with Rust and will allow you to do a number of things. So not just install dependencies, but even scaffold projects, formatting your code, and a bunch of other things. And it is extensible, and we will see an extension that can be used specifically for Lambda. And finally, there is a great ecosystem of libraries. So even if Rust is a relatively new language, so far, every time I needed an external library, I was able to find it in the package registry. And generally speaking, the libraries are very good quality. There are tests, there is documentation. So that's great to see that such a relatively new language already has a decent ecosystem of third-party libraries. And then there are other language features that I really like. For instance, pattern matching. There is no concept of null. The option and the result types are amazing as well. Now, I'm not the only one to like Rust. I don't know if you're recognizing this blog, but yeah, there is an article there that if you're interested, you can read, and you can see other opinions about Rust and other use cases for Rust in the AWS world. Now, I just want to give you a quick appetizer, so to speak, just to see a little bit of the Rust syntax and how it can be useful to understand, mainly to understand why I think Rust can also help us to write code that can be a little bit better. And by better, I mean that it's less likely that they're going to write bugs. Of course, you're not going to avoid every single bug, but the language can help you to write more correct code. And mainly I want to show you this concept of the result and option types, and I want to start with this example. This is a very simple example where effectively we have our main function and we want to read an environment variable, for instance, AWS region. Now, if you ever try to read an environment variable, you know that it's not necessarily obvious that the environment variable is set when you run your application. So your code might actually fail, or you might have all sorts of different problems if, for instance, the user forgot to set a specific environment variable. So this is something that generally in your code you need to think how to handle, and you might be handling it in many different ways. So in Rust, this is something that the language helps you to think about in a very interesting way. So when you read this variable region, you don't have a string as in many other languages, but instead you have an object that is of type result. And what result means is basically the idea that this object is a wrapper for one of two different types, either a string or an error. So the idea here is that if the user set the value, then this result will contain the string. If the user didn't set the value, then this result will contain an error. And therefore, we cannot simply just access the string and ignore the idea that there might be an error there. So we need to consider there is an happy path and a sad path and figure out how do we want to handle both. Now, one way is to use the pattern matching, which I mentioned before. And pattern matching is basically like a case or a switch statement on steroids, because you can do a lot more. But the idea is that it allows you to express different branches. And in this case, the branches are either is an okay, which means that we are able to get the string, or it is an error. Therefore, we need to figure out what we want to do with that error. So in this case, if it's okay, we are printing the region. If it's an error, we are printing error AWS region not set. So we are basically handling the two paths, the happy path and the sad path. Now, another approach might be, okay, if the region is not set, I want to just panic with a specific error, and we can do that using this expect. And what expect does is basically it's going to panic if the value is not set, but if the value is set, it's going to give you immediately a string value there in region. So it's kind of a shortcut to say, if I don't have this value, I cannot continue, so just panic. But if the value is there, just give me the value straight away so I can continue with the execution of my code. And finally, there is another approach, which is when you can use a default. So sometimes if the value is not there, maybe you can use a sensible default. And in that case, we can use this approach, unwrap or else, which allows us to call a function that will create a default for us if the user didn't set a region. Now, the point that I want to make is that Rust gives you in the type system primitives that will make it very hard for you to ignore edge cases like the possible absence of a value or cases where you might call a function that might fail. And it forces you to think about those failures, and you need to write code that somehow handles those failures in a way that makes sense for you. Okay, now let's focus into Rust and Lambda together. So the first thing that it's probably obvious is that Rust can help you to save money on Lambda. And this is because the invocation cost of a Lambda function is based on the amount of memory and the time in milliseconds that your function is running. So because Rust is a language that will help you to create very efficient code, effectively you have a binary that can be very, very efficient. That means that generally speaking, when you write code in Rust, that code can run very, very fast, at least compared to other languages like Node.js and Python. And the other thing is that because it generally is also very memory efficient, you can keep that memory dimension very low. So you are basically optimizing on both dimensions of cost when it comes to Lambda invocation cost. You can also have very fast cold starts. I already mentioned the concept of zero cost abstractions and binaries that can start very, very quickly. That means that generally speaking, cold starts are much lower than almost any other runtime. I think it's only competing with C++. And there is a benchmark there. You've probably seen that benchmark, but if you want to check it out, that shows the comparison between all the different runtimes, using different architectures, using different memory configuration. And you can see the Rust is almost always the first one, or maybe the second one competing with C++. You have multi-thread safety. Now, generally, you don't necessarily need to do multi-thread stuff in Lambda, at least based on my experience. But if you do, the language is very well built to deal with multi-threading in a safe way. And this is actually the reason why the language was invented in the first place at Mozilla. So if you ever need to do multi-threading stuff in Lambda, this is probably the best language you can use to do that in a fast way and in a safe way. There are no null types, and I already showed you an example of the result type, but there is also an option type that allows you to manage the absence of values. And that, generally speaking, helps you to prevent bugs. So I hope that this is enough to excite you, and I want to show you how to start to build Lambda functions in Rust. Now, I'm going to give you a super quick introduction. Andre already did a good job introducing me, so I'm going to keep it sweet and short. I work as a senior architect at Fortheorem. I'm going to tell you about that in a second. I am the co-author of this book that Andre already mentioned. So if you are into Node.js, you can check it out and let me know what you think. And I'm generally very friendly, and I'm available online at this link. You can find all my social networks where I'm available, but feel also free to ping me on Discord, and we can continue chatting there if there is anything you want to talk about. Now, a little bit about Fortheorem. Fortheorem is a consulting company specialized in the cloud and specifically in AWS and serverless. We do a bunch of different things. We've done a number of different interesting projects. We also have some blog posts published with AWS in their own AWS engineering blog. So if all these things are interesting to you, feel free to reach out to us. And I'm also happy to chat with you outside this talk. And one thing that we do at Fortheorem that I'm very proud about is we do a lot of content. We also have a podcast called AWS Bytes, where we are proud to do the most hilarious cover art ever, I hope. Everything else doesn't matter. You just need to like the cover art. Let me know if you don't. Okay, so let's get started. Where do we start? So we can start by trying to create a new Lambda function and trying to do that in Rust. So if we go in the AWS console, you probably seen this screen 1 million times. This is what you do when you want to start configuring a new Lambda function. And one of the items that we need to configure is the runtime. So if we click there, we open a list of things, and we can see that there is .NET, Java, Node.js, Python, Ruby, and then a bunch of other versions of the same. And you might be wondering, well, where is Rust? Like, yeah, we want to do Lambdas in Rust. It's not even there. But if we squint a little bit, we can see that Rust is listed here under Amazon Linux 2023, and it says OS runtime for Go, Rust, C++, custom. So it's just that easy. We need to create a custom runtime, right? Easy peasy. And you might be wondering, a custom run what? And if you never heard of custom runtimes, I'm going to give you a very quick introduction of how Lambda works internally. You can imagine that Lambda, it's effectively two pieces working together. On one side, you have your Lambda function, so basically your business logic. And on the other side, you have the control plane, so everything that the AWS needs to put into place to make sure that your Lambda can be executed at the right time. Now, when you write your Lambda function, actually your Lambda function is not just one unit. We are used to think only about the handler, so the business logic that we write. But in reality, there are actually two parts. And one part is called the runtime, and the other part is the handler, so the business logic that we want to write for our Lambda. Now, the runtime actually has a lot of responsibilities, but it's generally something that we don't have to think about when we work with runtimes that are managed by AWS, like Node.js, Python, Java, and others, because we can focus only on the handler, the business logic itself. But it's important to understand what the runtime does, because when we want to use languages like Go, Rust, or C++, we need to think a little bit more about the runtime and understand what the runtime does. So imagine that a new Lambda environment is being bootstrapped in your AWS account. The first thing that it happens is that the runtime takes over and it starts to poll an internal API for events. So it's basically asking to the control plane, hey, somebody's just spawned me up. Is there something I can do? So it's constantly asking for new events. At some point, the control plane is going to respond with an event. And this event, generally speaking, is a JSON blob that represents the information for that particular event. Now, at this point, the runtime gets that event, and it knows that there is a specific handler that it needs to execute. So that event is effectively propagated to the handler is executed, and this can change a little bit depending on the language of choice. It might be, I don't know, invoking a function, it might be something else. Maybe it's just a bash script that includes another file and it's executed, or maybe something else. But at some point, your custom business logic is running, is processing that event, and it can produce either a response or an error. And that response or error is propagated to the runtime that can then send that response as a JSON to the control plane. And the reason why this response needs to be sent back is because generally Lambda is used for integrations. So imagine you are building an API. What happens is that your Lambda is invoked with a payload that represents an HTTP request. It's doing some processing that request, creating a response. That response is a JSON that represents an HTTP response. Then that JSON is sent back to the AWS control plane, and the AWS control plane is responsible to communicate, for instance, to API gateway, what is the response so that it can be actually forwarded to the client that made the request in the first place through the HTTP protocol. Now, if you don't believe me that all of that is happening, I actually have a very nice demo. So if we go to AWS, I think I have open here. I actually started I created a new Lambda where I selected a custom runtime. And funny enough, what you get is something that is using Bash. So they tell you that you can do Go, you can do Rust, you can do C++, and then they give you a Bash example. But I think this Bash example is actually pretty cool. It's pretty clever. Whoever wrote this, I think, is a genius. It makes it really, really clear what's happening at the level that we just described, the runtime itself. So there are here two files, bootstrap.sh and hello.sh, and Bootstrap is actually one implementation of a runtime. And what it's doing is basically reading the source. So it's basically reading the actual handler, and then it's just going into a busy loop. So it's doing a while through. So this is always looping, and it's making a request. I mentioned that there is an internal API where you can poll to get an event. So it's constantly asking, hey, give me an event. And then at that point is executing the handler function with the event itself. And when there is a response, so when this finish, we have a response, that response is sent back with another API call to the control plane. Now, if we look at the handler itself, the handler is just doing an hello word, but you can see that effectively is a function that is basically the function that gets invoked here every time there is a new event. And you can imagine that this loop is going on and it's processing one event at the time until that Lambda environment gets disposed. Okay, back to the slides. Somewhere here. Now, of course, we don't need to write our code in Bash. Also, we don't need to recreate an entire runtime in Rust. Thankfully, AWS has done that for us. And it's an open source project. It's effectively a Rust library that AWS maintains. And that Rust library implements all the logic that we just saw in Bash, with probably a lot more happening to handle a few edge cases. But effectively, this is what this code is doing. And what we need to do is just install this as a library. We will see that in a second. And then we just write our handler code. So our final experience as developer is not too different from the experience that you would have when you write Lambdas in Python or in Node.js. Of course, we need to be a little bit more aware of what's happening behind the scenes. We need to understand what this library is doing, but we don't need to write all the business logic that we just described for what a runtime needs to do. So where do we start? Of course, you need to install Rust. And Rust actually comes with a very nice tool called Rust App. I generally recommend people to install Rust through this tool. This tool is effectively an installer that makes it easier for you to install and keep Rust up to date, but also allows you to install different bits and pieces of the tool chain. Sometimes you need different backends. For instance, if you need to compile for ARM or to cross-compile or other extensions, Rust App makes installing all of this stuff way easier, and it works cross-platform. The other thing is that we need to install Cargo Lambda. I already mentioned that cargo is the package manager for Rust, and it's very extensible. There is an extension that is also maintained by AWS that gives you a lot of useful commands for using Rust with Lambda. Basically, the things that you can do, and we will see that in a second, is scaffold a new project. You can compile, cross-compile, local test, publish your Lambdas. So it gives you basically all the development tools that you might need when you want to build Lambdas with Rust. Okay, now I have here some animations that you can check out later, but I want to go into a little bit of a live demo if we have time. So here I already created an environment. So let's do a new project where we say, let's do an S3 Lambda first. So we go here into S3 Lambda, and as I already have a start Rust and cargo Lambda, so what I can do is cargo Lambda init. And what init does, it gives you a few prompts so that you can get started from a project where all the scaffolding is done for you and you don't need to start from scratch. So this tool tries to lower the barrier to entry to create your first Lambda in Rust. And the first question that we get is, are you trying to build an HTTP type of Lambda function? And because initially we just want to try a function that does S3 stuff, so process objects that are uploaded, for instance, to S3, we are going to say no here. When we say no, actually we get access to another list where there are lots and lots of events that are already built in there. And we can even type, for instance, if I type S3, it's going to filter out for me. And what we want to select here is S3 event, which is the basic event that is triggered when you connect an S3 bucket with a Lambda. Okay, at this point, something happened. So what we can do is do an ls, and we can see that some file was created for us. So we can open this with Visual Studio Code. Hopefully this is readable enough. I'm going to make it a little bit bigger for you. And we can see that all this code was generated for us. And there are a few interesting things that I want to show you. So first of all, Lambda runtime. So this is the library that I was mentioning. The runtime built by AWS and provided as a third-party library is automatically installed for us and made available in this boilerplate. The other thing is that there is a main function. This is the first thing that gets executed in a Rust binary. And this main function is generally not something we need to touch unless we want to do something at init time. But what this main is doing is just using the Lambda runtime, using this run function, and then linking it to our function handler. So what this is doing is basically implementing that loop that we saw in Bash, and it's configured to call our function handler every time that there is a new event. So basically at this point, we can pretty much ignore all of this and all of this and just focus in writing our business logic. And the cool thing is that because Rust is a typed language, we have access to a very good set of typed events. So we have this kind of high-level Lambda event, and this Lambda event contains both the current event and the context. So what we can do is do something like event and context and do event into parts. So this is basically giving us the current S3 event and the current context. And you can see, for example, that everything is typed. So if we do context, we can see, for instance, deadline, which gives us the time that is remaining before the function times out. Or you can read things like request ID, you can read X-ray trace ID, and a bunch of other stuff that you generally will find in the context. Of course, we are more interested in the event right now because maybe what we want to do is just log all the files that we can find, all the objects that we can find in this event. You're probably familiar with S3 events. Generally, it's not just one S3 event, like maybe somebody uploaded one object to a bucket, but it is effectively a collection of events that might have been happening in a short amount of time. So what we can do, for instance, if we can do event, actually, let's do it this way. We can do for record in event.records, and we can say this is the record, right? We can print exactly the information about the record. Of course, record is going to be typed. So if we wanted, we could do S3 object key, or we could do S3 bucket, I think, name. So the type system is going to help us to make sure that we access all the properties that are available in that event. Also, some properties are optional. They're not always present in the event. And again, the Rust type system helps us to understand that every time there is an optional property, we don't get the value straight away, but we get an optional object. And that optional object forces us to think, okay, what do I do if the value is not there? Can I just unwrap, which basically means if it's not there, my code is going to explode? Or maybe do I need to do like an if statement or a match expression to handle all the possible different cases? Now, at this point, we have code that is doing something not really useful, but something we can test. And the next step is how do we test this, right? So if we go back to the terminal, which is somewhere, where is my terminal? Somewhere here. What we can do is we can run a few commands. And the first command I want to run is called cargo lambda watch. And what this is doing is basically compiling my function, but it's also creating a local simulation environment. So that's why it was asking me whether I want to open a specific port, because of course it's listening on a specific port. And then in this other terminal, what I can do is basically invoke my Lambda function. So we can do invoke data example S3 event. Actually, Cargo Lambda also has a set of predefined events, the most common ones. For instance, S3 event is one of those. There is a list you can find on the website. And if you don't like that, of course, you can pass your own custom events either to a file, or you can even do, I think it's data ASCII if you want to type the event here. So if we do this, this is going to actually send the event to our local simulation. And we can see here that we get a response straight away. Of course, it's a little bit verbose because we logged the entire record. For every record, we were logging the record. But you can see that there are things like, where is it? There should be like a bucket name somewhere. Let's see. Yeah, we have source bucket, the ARN, my bucket, and there is also a key, which is happy face, JPG. So this is, of course, a sample event. Assume that somebody was uploading this happy face JPG in a bucket, and you want to process that particular file. Okay, hopefully that gives you an idea of how you can start using Cargo Lambda to create your first Lambda. Now, we discussed all of this through the live demo. The next thing is that we said that because Rust is strongly typed, we have access to strongly typed events and responses. So here what we got was effectively a request, and here what we have a response, and both of them are strongly typed. So it makes it easier for us to make sure that we are conforming to the specifics of both the request and the response. But you might have this question, what if I want to use different types? Maybe I'm not doing an S3 Lambda, maybe I'm doing a Lambda that uses API Gateway, or maybe uses SQS, right? How do I do all of that? And there are a few different options. If you're using AWS Events, there is actually a crate called AWS Lambda Events, again, maintained by AWS, and is the one used by default if you use Cargo Lambda. And this crate has all the events that we saw when we did Cargo Lambda in it. So you can just scroll in here and you will find, I don't know if it's very comprehensive, but it's probably close to be comprehensive, but all the events that generally you might want to use. And you can see that there are things like even Lex, RabbitMQ, and code deploy. So things that maybe are not so common to be used. And I can show you another example where it comes to processing jobs from SQS. Now, you might be aware that when you integrate Lambda with SQS, you are effectively pushing jobs into a queue. And then on the other side, you are polling for these jobs from Lambda functions. And the polling doesn't really happen from the Lambda itself. There is a component in SQS called Event Source Mapper, which effectively polls for you and then invokes your Lambdas when there are new jobs available in the queue. Now, if you want to implement this, basically what you can do is you can do again a Cargo Lambda init and then select the SQS event. And what it's going to do is going to do all of this for you. So it's going to install this particular library, AWS Lambda Events. It's going to enable the feature flag SQS, which makes the specific SQS events available for you. And then it's going to create some boilerplate code for you. And the cool thing that I want to highlight here is that you don't just get the SQS event in the Lambda event, so the request is not typed, is not the only one to be typed, but even the response is typed. And I really like this particular example because one thing that is a common mistake that almost everyone does with SQS is not thinking what happens when you have a partial success. So with SQS, you receive an array of jobs. You don't receive just one job in the majority of the cases. And you might be in a situation where you start to process all these jobs in your Lambda function. And let's say that you have 10 of them, maybe 9 of them succeed and 1 fails at the end. What do you do then, right? By default, if your Lambda just fails, what happens is that the entire batch is sent back to SQS, and then at some point you're going to retry everything again. And that can make your code a little bit complicated if you want to handle error gracefully or if you don't want to reprocess jobs that have already succeeded. But what you can do with Lambda is you can return a response that describes which jobs have failed and which ones have succeeded. And by using Rust, you can access this type called SQS batch response. And this type is going to guide you to create the correct JSON response that you need to return from Lambda so that the SQS integration works as expected. And basically here, what we are doing is we are doing a loop over all the records, doing some kind of processing. And then if this job is failing, we just push it in a list. And we push specifically the record message ID. And then we return this response where we have batch item failures, and this is a vector of all the IDs of the jobs that failed. When we do this, let's say that one job over 10 job failed. Here we are going to have the ID of that job. This Lambda completes. SQS receives the response, and it knows, okay, from these 10 jobs, 9 of them are succeeded, so I can remove them from the queue. But this particular one failed, so I need to reschedule it so that it can be retried later on. So this is just an example where having a type system both in the input and the output of our Lambda can help us to use the integration correctly. Now, the other option is, what if you need to have a custom request or a custom response or both? And the most common use case for that is when you're doing, for instance, step functions. When you're doing step functions, you might have a number of steps that are totally custom to you. You need to provide your own business logic, and it's common to implement that with a Lambda. And because it's totally custom, you will have a custom input JSON, and you probably need to provide a custom output JSON that goes as part of your state in your Lambda function. Now, this is a real use case that I implemented and actually did a series of live streams where I was effectively rewriting this step function that I use for automating a newsletter that I manage called Full Stack Bulletin. And I was rewriting some of these steps in Rust just for fun, just as a learning exercise. And as I was doing that, I did a series of live streams. So if you're curious, you can see those live streams on YouTube and just watch the recording, and hopefully they can be interesting for you. But one particular example I want to show you is this first Lambda here called fetch issue number. What this Lambda does is basically every time I generate a new newsletter, I need to know what was the issue number of the previous newsletter, because the new issue number is going to be that number plus 1. So what I'm doing, because I'm trying not to keep a database as much as possible, what I do is a little bit nasty, but it works. I basically scrape the web page where there is the list of all the issues, and I take the first one, get the number, and then increment that number by 1. And this is effectively the business logic inside this particular Lambda function. And there are 2 libraries that we need to use to deal with serialization, deserialization, specifically JSON. This is Serde, that is a generic serialization, deserialization library. And then we have Certi.json, which is the specific implementation for JSON. When we have these 2 libraries installed, what we can do is we can create our own custom structs. So you can imagine structs as, objects in other programming languages with a very well-defined structure. And in our case, the request is going to be the URL that we want to scrape, and the response is going to be the issue number that we found in that particular URL. And then what we are doing here, this is the request. and this is the response. And by adding these annotations that you see in line 3 and line 8, we are effectively making these two structures. The first one, the serializable. So this is going to be a JSON that comes in and we need to be able to convert to a Rust object. And the other one is serializable, which means this is an object that we construct in Rust, but we want to convert in JSON. And of course, the two are not mutually exclusive. You can make a struct that is both serializable and deserializable. Now, what we need to do here is you can see that the signature of our Lambda function has both a Lambda event request, so using our own custom type, and the response as a result response. So again, we can use our own custom types once they are deserializable and serializable, respectively. Then at this point, I can do here all my own business logic. And finally, I can return a response. So here, basically what we did, we created custom types and use them in our own Lambda definition. So inside our handler logic, everything is strongly typed, and we are reducing the chances that we are doing mistakes just based on accessing the wrong parameter, or maybe trying to read something that is a string as a number, or vice versa. Common mistakes that can happen in Python and JavaScript, for instance. Now, here I have another example that shows how to debug this particular Lambda. Is exactly the same. You just do cargo Lambda watch on one side, and you can do cargo Lambda invoke on the other side. Here, the invoke, because I'm using a custom event, I can just use the parameter data ASCII to pass a custom JSON that I want to use. Okay, there is one more possibility. Let's say that you are building a Lambda that can accept any kind of JSON. Maybe you can send different kinds of payloads, and I don't know, it does different things. Maybe it tries to find all the URLs, maybe inside a JSON, traversing all the possible properties. Something crazy like that. It's a very niche use case, but it can happen. And of course, we can also handle this particular use case in Rust while still using an interface that is fully typed. And the way it works is by using this concept of JSON value. A JSON value is a specific concept in this SERD library. And what it does, it basically represents all the possible types of values that you can have in JSON. And in JSON, you know that you can have a null, you can have an array, you can have an object, you can have a string, and then, of course, you can nest different things. For instance, you can have an array that contains an object, and inside that object, you can have a property that, I don't know, is a string, and so on. So value, what it does, allows you to basically specify how you want to traverse that object to try to read the different fields. And it can get very verbose because, of course, since Rust makes sure that you think how to handle all the possible errors, you have to think, okay, I want to read the event payload, and I'm going to assume it's an object, which is not necessarily true because a JSON value can be an array, for instance, or it can be a null, so it's not necessarily an object. So what if it's not an object? And you have to decide what to do. If you just do an unwrap, as we see in line 9, that means if it's not an object, I'm just going to panic and crash the entire function. Then the next step is, okay, now that I have an object, what do I want to do with this object? I want to read the property URL. And that property might not be there. So what do we want to do if it's not there? Unwrap again, which means if it's not there, I'm just going to crash. Then that property can be any other value. So what do we want to do with it? Let's assume it's a string. And again, that might fail. So we need to think how to handle all of that. And you can see that this can get very verbose, but it's also interesting that it's very, very explicit, and it really makes you think hard about every single step. Are we sure that we are able to proceed in the happy path? And if not, how are we going to handle the unhappy path? And this is, I think, really, really good thing to have in any language. You can probably do that even with TypeScript or with type Python. I'm just saying that in Rust is kind of the default way of doing things, and you have all these different utilities like unwrap or all the helpers function that you have with the option or the result type that makes processing all these different paths a little bit easier. Okay, now let's see if we want to do an HTTP-based Lambda, and I want to do this with another demo. We don't have a lot of time, so I'm going to try to be quick. And let's do HTTP Lambda. And what we want to do is, again, cargo Lambda init. And this time, we are going to say yes to this particular question. Do you want to do an HTTP function? Of course, yes. Let's do that. And if we go to if we open this with Visual Studio Code, we can see the code that was generated. I'm going to make this, of course, a little bit bigger for you. So again, it's generating a bunch of files, a cargo toml where it defines all of the dependencies, and then a source folder with a main file. Now, again, the structure here is very similar to the one before. There is a main that uses the run function from the runtime library, and then it connects that to our own function handler. So again, for the most part, we can ignore the stuff and just focus on our handler. And the cool thing here is that it did create a few interesting things for us. It's not just the input and the output, but there is some business logic here, which is nice. So the first thing that we can notice is that we have a request and a response body. Now, this is a little bit of a higher level abstraction that we get with HTTP Lambdas, and it's part of another library called Lambda HTTP that builds on top of the runtime just to provide a slightly better integration with HTTP. So here we can think a little bit closer to the concept of an HTTP request and an HTTP response. And as you can see, this request object can access things like query string parameters, and you could access path parameters. You could access other things that are very common to use when you are dealing with HTTP requests. And also gives you a response builder, so a builder object, so using the builder pattern, so that you can easily construct HTTP responses. So you can provide the status, you can provide headers, you can provide a body, and so on. Now, this is the most typical HTTP API, an hello world, where you can optionally specify a name parameter, and it's going to tell you hello, whatever. Or if you're not providing any parameter, it's just going to tell you hello world. So now you might be wondering, okay, how do we deploy this function? Because so far we have seen only the local development experience. What if we want to deploy this? And what we can do is cargo lambda build release, and the release flag is effectively doing some additional optimizations to make the binary more performant for production. And then we can say cargo lambda deploy. I believe I have credentials here, so let's see what happens. Now, this is effectively compiling our code for production. For production, it generally takes a little bit longer. With Lambdas, you're still managing very small amounts of code, so it's generally manageable. It's definitely below 1 minute, I would say, for the majority of the examples I've seen. But because it's a build for production, it takes a little bit longer than a build for debug because it's doing additional optimizations on your binary. Now the compilation is done, and the code is being uploaded to AWS. And can take up to 20 seconds. Let's see if it's true. Deploying function. Okay, our function is deployed, and we can see the ARN. So now I think I have AWS open somewhere. Yeah, there it is. So we should see here another function. Hopefully I deployed to the right account. Yes, HTTP Lambda is what we just deployed. So this is the code we just deployed. And you can immediately see, hopefully, a couple of problems. The first problem is that there is no trigger, right? How are we going to run this Lambda? And this kind of makes sense because we didn't say anywhere, for instance, that we want to use, I don't know, API gateway to manage the incoming HTTP requests, right? So Cargo Lambda just didn't make any assumption for us and just said, I'm going to deploy your Lambda. Then you go and figure it out how to connect the specific trigger for that Lambda. And the other issue, which maybe is not that surprising, here you can see the code editor, but if we go to Bootstrap and we try to open it, well, here we get this error because somehow the package now is over 3 megabytes in size. But I had other instances where you can see the content of it, and effectively this content is binary rubbish that you cannot read because this is not just source code, this is compiled code, and it's going to be a binary. So it's a little bit misleading that here you see a code editor, but in reality, this is not the way you edit code in Lambda functions in Rust. You'll need to go through a cycle of recompiling them and re-uploading the compiled artifact. So this editor is not really something that's going to be very useful for you when doing Lambdas in Rust. So what are we going to do? Like, we can test this function by invoking it from here, from the test, by sending an HTTP event. But there is actually another thing I want to show you, which is if we do cargo deploy and let me check what was the actual property. Yes, we can say enable function URL. What did I do wrong? Cargo Lambda, sorry, deploy, enable function URL. I forgot to specify Lambda. And what this is doing is basically going into our function and enabling the option function URL. Now we have a URL that we can visit. Of course, this is super small, but you can see here that it's saying, hello world, this is an AWS Lambda HTTP request, and we can edit the URL. You probably cannot see that, but trust me, I'm passing a name. And if we refresh, we get hello, believe in serverless. This is an AWS Lambda HTTP request. Okay, so now back to my slides, and I'm going to run through the rest of the presentation. We cover all of this. And we already covered how to do the build and deployment. We even saw all these problems and that you can enable function URL. Now, how do you solve the problem of no events? Of course, this is not the way you want to deploy Lambda function in Rust, because most of the time you want to use infrastructure as code. You are not just deploying one Lambda function alone, but you are deploying a bunch of resources that needs to be properly connected together. You can do infrastructure as code for Lambdas in Rust using SAM. You can also use CDK, you can use Terraform. I'm just going to show you quickly an example with SAM, because to me, it's probably the easiest to showcase. And the cool thing is that SAM is already integrated with Cargo Lambda, because they are both maintained by AWS. Of course, that makes it a little bit easier. There is a native integration. And the idea is that you can define all your infrastructure as code with the power of SAM, so using YAML. And then when you define Lambdas in Rust in that YAML and you deploy, that build and deployment is done using Cargo Lambda behind the scenes for you. So you don't need to manually run Cargo Lambda commands. SAM is going to do all of that for you. It can also simulate API gateway locally. So the local simulation that we saw with Rust can also be integrated with the simulation that exists with SAM. So it's going to give you effectively a local HTTP endpoint that you can use when you're doing your local test, when you integrate the two together. Now, the way it works is that it requires a little bit of additional metadata. So when you define a Lambda function, you need to tell SAM that that particular Lambda needs to be built using Cargo Lambda. So you need to include that additional line there. And then the other thing is that the handler needs to be bootstrap, because it's just going to be a binary. And the runtime needs to be Linux, Amazon Linux 2023. And finally, you can define your own triggers. And as you might expect, when you deploy all of this infrastructure, that trigger will be configured with you, an API gateway will be configured, the methods will be configured and connected correctly to your Lambda. And the way you do all the building and testing and deployment are the usual way that you will do it with SAM, if you've used SAM before. Here, I'm just going to gloss over all these details. I'm just illustrating how to do all the build and deployment. So trust me that all of that works, and you can test it later on if you're curious. So some closing notes. I think that Lambda is great, but you knew that already, right? So this is not news. Hopefully what is new, and you believe me now, is that using Lambda and Rust together can be fun, can be very productive. It can also be very cost efficient. So I think it's an ideal combination using Rust together with Lambda. It is true that it's still a little bit of a niche use case. We don't see a lot of examples online. There are a few people that are being very vocal, and they are providing a lot of very good material, and that's great to see. At the same time, it's really interesting to see that the developer experience is already quite good. Even though it's still a niche use case, AWS is investing a lot, and all the tools that I showed you today hopefully confirm that there is a big commitment from AWS in making sure that building Lambdas in Rust is as easy as possible. So my suggestion to you is try it. have fun, and then everything you learn, share it, because this is how we build more material and encourage more people to try it. And this is going to help the ecosystem to get even better. Now, if you want to know more, I have some additional resources that I want to share with you. This is a full example that I built using Cargo Lambda and SAM. It's not just Lambda, it brings together a bunch of other resources. And effectively, this implements a monitor for earthquakes. Every time that there is an earthquake that is somewhat close to my family, this is a Lambda that runs on a schedule, and it can notify me that that earthquake happened, and I can check on my family. I have another one. This is actually something I built for work. We were working with a customer that needed API gateway authorizer, and it needed to be very performant. So we decided to write it. Actually, initially we wrote it in Python, and then we were receiving so many requests, and we thought, how can we make this a little bit more efficient? We rewrote it in Rust, and the benchmarks are actually quite interesting. In that repository, it's fully open source. You can get the code. It's also available in the server's application registry if you want to use it. And also there is another repo with all the benchmarks if you want to check that all the numbers and the way we benchmark it makes sense. And finally, if you want more, there is another thing that I'm working on together with James Eastham that I'm sure you know from the Believe in Serverless community. We are working together on a book called Crafting Lambda Functions with Rust. The book is already available. It's published as a preview mode, which basically means that as we publish new chapters, still is going to be draft of chapters, but you can buy the book at a discounted price and you get all the updates as they come. And right now it's available in early access with 50% of what we think is going to be the final price. So hopefully that makes it appealing. But we wanted to provide an extra 10% discount for this community specifically if you use the code BELIEVE. I think that code is limited to the first 10 people. But yeah, if it doesn't work for you, let me know. We can probably create more codes. And that's everything I have. I don't know. I think I went 5 minutes over time. So I don't know if we have time for questions. I'm happy to stay a little bit longer.
And I'm back. Good stuff. A lot of information. I love all the tooling there's around it already that helps it make it a little bit simpler. Good stuff. There aren't really any questions in the chat. I do have a few though, and it's more just around the language itself and your experience with it.
Mm-hmm.
Right. So how long have you been working with Rust now?
Yeah, I haven't been working too much with it professionally. It's been a little bit of a side quest or a hobby, if you want. So something that I've done probably for the last 4 years, 4 years and a half, but very sporadically. It's not like I was spending, 5 hours a day coding in Rust, probably, once a week or something like that. Or maybe reading a few books over time. And it is true that Rust has a bit of a reputation of being hard to learn because there are lots of new concepts. For instance, the idea of borrowing values or moving values that are not very common in other languages. So you need to kind of buy into that mindset and understand how to write code that respects those principles. And I think that can be a little bit of a friction. But today is not as hard as it felt, I think, 4.5 years ago, where there wasn't a lot of material. I think now there is lots of material, lots of great tutorials, so that it's easy to kind of overcome that initial hurdle. And as soon as you start to be productive and build something that works with the language, I think you start even enjoying it. And then, of course, it becomes easier to keep learning and getting better at it.
Cool. And I mean, you've mentioned it's gotten easier to learn and all that since there's more content around it. But just at the basic level, how would you compare it to learning like JavaScript or C# or Go or any other language? I know all of them are different, but
yeah, it's a difficult question. I think it's maybe a little bit unfair to Rust because you can go so low level with Rust. Like when you start using all the references and like the more advanced features, like even the generics or the associated types, it can get very complex and intimidating. But the truth is that you don't need to use all these things from day one. Like you can use them as you need them and as you become more confident with the language itself and you want to explore more features, maybe to write even more optimized code. There is actually a really good talk by Andre Bogus. I'll try to find the link and maybe put it in the chat, which is called Easy Mode Rust, that actually gives you all the tricks that you can use to basically keep Rust as simple as possible for the first time you use it. So for instance, you try to avoid references as much as possible by doing clones. And it's considered a bit of a bad practice, but really it's not going to affect necessary performance so much if you think that all the other languages like Python or Ruby or Node are doing memory copies all the time. You just don't realize it, right?
Okay.
So it's more like if you are an hardcore performance engineer, it's like, oh, that's bad. You shouldn't be doing that. You should try not to copy any memory ever. But then in reality, you can take a little bit of a leeway just to keep the language simpler and make it easier to learn as well. Make it easier for you to achieve the objective you have. And then if you have time to optimize, you can invest more and use the more advanced features. So I think
cool
that's the right
cool
mindset for people.
Yeah. It's cool that you have kind of layered, right? And you can start simple and that making it more maintainable. I know that's a big issue in just any language, any infrastructure. If you're too clever to optimize for 1 millisecond, but it's super unmaintainable and nobody else can do it, then was it worth it, right? So you really have a point to evaluate your trade-offs with Rust and have it, like you said, there's an easy get started, and maybe that's all you need, right? And maybe you don't need to dig into the internals and all that.
Yeah, and I would say that for Lambda, that's even more the case, because generally you are writing smaller units of code, and the overhead is going to be more on bootstrapping the environment and all the integration points. So what you want to do is basically have something that is performant enough so that your call starts are low and your execution times is low. But even by taking a little bit of freedom and not being the most performant Rust code ever, you're still going to be probably more performant than all the other, maybe not all the others, because I think it's still going to compete with Go and C++, but you're still going to be among the fastest implementation of that Lambda that you can achieve.
Cool. We do have a question from Mohammed on, are there any resources you recommend for learning Rust?
Yes, so there is a very good book that is actually called the Rust book, which is, you can buy it if you want the print version, but it's totally free. You can find it online. And actually, I think there are two versions. I read recently that there was a study from a university, I don't remember which one, where they actually took this book and they tried to create challenges and variations of the book, trying to figure out what resonated better with people, what was more approachable. So I think there is a second version. I'll try to find the links where it's even more optimized for basically approachability, making it easier to learn Rust through this book. I would say that this is definitely the first thing you should read if you're interested in Rust. Another one is Zero to Production in Rust by Luca Palmieri. It's another book, and it's more of a what it takes to build a web project with Rust. And the book is like one of the best books I read in terms of building a product. Even if you don't care about Rust, like it really gives you that mindset of, okay, what are the requirements? What are the tests? Let's build a feature. Let's make it fail. Let's make it green. And progressively, you learn more concept as you see that product taking shape. So that's a great book that I would recommend if people want to take a little bit of a more hands-on approach and they want to feel I'm not just learning a thing, but I'm also building something with it. So these are probably good resources. Otherwise, you can find lots of like code-based approaches. Like for instance, I personally learned it a lot by doing Advent of Code in Rust. So if you want to take more of I want to solve an exercise or I want to solve a problem with Rust, there is no shortage of resources there.
And obviously, crafting Lambda functions in Rust by you, I would recommend that one.
Yes, although we don't necessarily explain all the details of Rust, at least the current stance on it is that we want to focus more on the specific of Rust and Lambda. Of course, we explain some of the more advanced concepts that we might use here and there, but generally speaking, we assume that you know a little bit of Rust, at least you are comfortable reading Rust code and you understand the syntax.
Cool. do you, let me formulate this question, right? Because you had some struct definitions, right? Once you were introducing the serialization, deserialization, all that. And one thing that usually comes up is like project structure and how to best and optimally structure my project in the code to better work with Lambda, right? Because you can have it structured differently for different use cases. But specifically for Lambda, do you have any opinion? Are there many opinions out there on how to structure your projects? Like in the JavaScript world, it's like, okay, you would put your package JSON here. This is how you would manage your dependencies and all that stuff. Is there something similar and an opinion already generated for that in Rust?
That's a great question. James and I are actually currently working on 2 new chapters of the book that cover code structure and testing. Honestly, we don't know if there is a agreed best way of doing these things. I think we are trying to come up with our own version of what looks good and then try to get as many reviews as possible and adapt the content based on what other people think as well. So yeah, that possibly answered the first part of the question.
Yeah.
But I think that there are easy enough ways so that you can do all the things that you need to do with a serverless project. And by that, I mean that, generally speaking, a serverless project is not just one Lambda, but it's multiple Lambdas. Yeah. Often enough, you have shared code that needs to live across all these Lambdas. Maybe you have, I don't know, models or object definitions that you define once and you want to be able to reuse across different Lambdas. So how do you do all of that? And actually, Rust is pretty good in that sense because with Cargo and the package management system, it comes with the concept of workspaces built in. Mm-hmm. So you can buy into that and say, okay, every Lambda project is a standalone project, but part of a workspace. And then I can have a library that is also part of that workspace. And therefore, all the other Lambdas can easily reference that Lambda, which effectively is like everything in a monorepo, but as if they were independent Rust projects connected together. So every Lambda can have its own dependencies without conflicts, but then they can easily reference things when you need shared libraries. So that's one thing that I think I really like from Rust.
And that's super handy with a strongly typed language. You probably want to share those models across Lambda functions or the request, the response, the types. So that's cool. And I'm a big fan of opinions because you got to start somewhere, right? And I can't formulate my own opinion until I see someone else's. And again, I would love to see like, hey, this is more optimal for dependency management or for running tests and all that. Because again, even in JavaScript and all that, everybody has their own structure that works for them. But once you have people's opinions out there, you can choose which one works best for you, right? So I'm happy you and James are working through that to get at least what your opinions are around it. And it might work for some people and it might not, and they'll form their own opinions or build something afterwards after that. So
yeah, absolutely. Hopefully we will be able to cover all these topics in the book. At least this is the idea where the book came from, because it's easy to do an hello word. I think the tooling and the kind of tutorials that you can find online are already there, and everyone can do an hello word in like 15 minutes. Yeah. Then I think the problem is next when you say, okay, now I want to build my next startup entirely in serverless and Rust. I think there is still a vast land that people need to explore and figure out exactly, as you said, what are the best practices, what are the common problems, what is a structure that is generally good enough for the majority of projects, and it can be a starting point. So hopefully with the book, this is what we are trying to explore with this book, but hopefully we'll be able to achieve a good result and provide good material to people.
Good. Well, we appreciate your time and showing us and helping us learn a little bit more about Rust. I do want to call out, this is turning out to be a bit of a rusty week. We got another session scheduled for Thursday where we're having Cliff Crossland comparing Rust versus Go, Java, and Python in a Lambda function. So a little bit of a different angle. And we'll get a little bit of comparisons with languages we use and know already. So I hope everyone can join us there as well. Luciano, again, thanks a lot. Great stuff. I learned a lot today.
Thank you. That makes me really happy. By the way, I posted some links in our private chat. I don't know if you can relay them to the public chat.
Okay, let me do that before we close it out. So 0 to Prod, that's the book.
That's one of the books. The previous one is the official Rust book. And then the previous one is a talk, the Easy Rust talk.
Okay, let me get to the book.
Thank you.
Just so everyone
Thank you so
can
much
go
for doing
here.
that.
And we'll close it. Okay, so I sent the 2 links. Oh, I sent the best believe in serverless. And there's the YouTube talk you were mentioning. Okay.
I can probably post those also on Discord if that's easier for people.
Yeah, and we'll add them to the show notes just so we have them there as well for people who watch this later. Hopefully we get a lot of people, a lot of views, so people can learn more about Rust. Cool. So appreciate it again. Hope you have a great rest of your day and hope to see everyone on Thursday.
Same. Thank you so much. Bye.
Bye-bye.